Hi, hello everyone. Welcome to SK Academy of Mathematics. Today we are going to learn how to solve the problem on Weddle's rule. Here we are going to consider the integral function. Without integrating this integral function, we are going to represent the value of the integral function by using Weddle's rule. First, we are going to represent the formula, represent the terms, integral limit point, lower limit point, upper limit point, represent the function with respect to the whatever they have given with respect to the variable, represent the what n ordinates, we call it as, or the interval. Then we are going to represent the interval with respect to x and y represent the function value, simplifying the Weddle's rule, and represent the approximate value of the integral function. How? Now let us see. First, represent the Weddle's rule. Solution: Weddle's rule is given by integral x naught to x naught plus n into h y dx, which is equal to 3h by 10 into y naught plus 5 into y1 plus y2 plus 6 y3 plus y4 plus 5 y5 plus y6 plus y6 plus 5 y7 plus y8 plus 6 y9 plus y10 plus 5 y11, this is 5, okay, y5 and y12 plus etc. goes on up to y n minus 6 plus 5 into y n minus 5 plus y n minus 4 plus 6 y n minus 3 plus y n minus 2 plus 5 y n minus 1 plus y n. This is the, see, please remember, this is the standard formula of the Weddle's rule. Considering this formula itself, we are going to represent the approximate value of the given integral function, that is I, which is equal to integral 0 to 4 1 divided by 1 plus x cube dx, where this can be represented as integral x naught to x naught plus n into h y dx, where x naught represents 0, x naught plus n into h represent 4, and y equal to 1 by 1 plus x cube, and n represent the interval. But always remember, in the Weddle's rule, n should be the multiple of 6. N should be multiple of 6. What the point? So, but they have given 7 ordinates. So what I am going to do? 7 minus 1, n equal to 6. Say 6 is the multiple of 6. So we are going to do ordinates minus 1. Then we are going to reduce n from 7 to 6. That is, 6 will be the multiple of 6. Okay, done. Now considering this, I am going to represent the h, that is x naught is 0 plus n, I have 6, h which is equal to 4, h equal to 4 by 6, h equal to 4 by 6. This I can represent it as common difference. Common difference. That means the interval, see, now I need to represent the interval x corresponding to that interval. I need to represent the function value y, that is, what is y? 1 by 1 plus x cube. We can represent y is also equal to f of x. This function I can represent it as f of x. Now I need to represent the interval. How to represent the interval? Remember, see, our interval is starting from 0 to 4. Okay, in between this interval, I need to represent the interval, so that between this interval, including 0, between this interval, the common difference should be 4 by 6. or 2 by 3. You can represent all the common difference should be 4 by 6, including 0 to 4. Got the point? Yes. Now, see, this will be our start, this will be our end value, and this will be our step in the calculator. Okay, remember this. I am going to show you in the calculator. First, take the calculator. Okay, done. Press mode setup. Press 7. F of x is given. Now represent f of x, that is numerator and denominator. 1 divided by 1 plus x. X cube I have. So what I am going to represent? Alpha, closing bracket, you get x. Shift x square, you get x cube. What? Now press equals. Start. I have told you start will be from 0. End is till 4 and step is 4 divided by 6. Press equals. You get the values starting from 0 ending till 4. Got the point? This will be the interval. Corresponding to this interval, we can represent the function value, that is f of x. Got the point? Yes. Okay, let us represent the terms. See, for 0, starting from 0, I have 0 point, no, for 0 I have getting 1. For 0 I have 1. Next I have 0.6666, 0.7714. Next I have 1.3333. For that function value 0.2967. Next I have 0.1111. Next I get 2.6666, 0.05. Next 3.3333, 0.0262. Last, that is 4, I get 0.0153. Got the point? Yes. This I can represent it as y0. This I can represent it as y1, y2, y3, y4, y5 and y6. See, represent the table so that there will be no confusion while considering the terms in simplification of the Weddle's rule. So we represent the table. Got the point? After representation of the table, now let us simplify in the formula. Till where? Till n equal to 6. Okay, by using Weddle's rule, we have, that is integral x0 to x0 plus n into h y dx, which is equal to 3h by 10 into y0. See, still the value of n interval is 6, so I need to consider till here itself. Okay, if they have given 12 intervals, I am supposed to consider till here. Okay, done. Now y0 plus 5 into y1 plus y2 plus 6 into y3 plus y4 plus 5 into y5 plus y6. At the point, after this, represent integral. See, x0 to x0 plus n into h y dx, I can represent it as integral 0 to 4 1 by 1 plus x cube dx, which is equal to 3 into, what is the value of h? H, I have 4 by 6 divided by 10 into y0. What is y0? 1 plus y1, 5 into y1, 5 into y1, 0.7714 plus y2, that is 0.2 967 plus y3. Y3 is multiplied with respect to 6. 6 into y3, 0.1111 plus 0.05 y4. Next y5, that is 5 into y5, 5 into y5, that is 0.0262 plus y6. What is y6? 0.0153. Okay, you can go with respect to direct calculator and represent the solution of the integral 0 to 4 1 divided by 1 plus x cube dx, which is equal to, okay, use the calculator, represent the solution. Okay, now take the calculator. First we have 3 into 4 divided by 6, close the bracket, whole divided by 10 into, open bracket, 1 plus 5 into 0.7714, close the bracket, plus 0.2967 plus 6 into 0.1111, 4 times of 1, close the bracket, plus 0.05 plus 5 into 0.0262, close the bracket, plus 0.0153. Done, close the bracket, you get the value 1.2033. We get 1.2033. Okay, this is the approximate value of the given integral function. Integral limit varies from 0 to 4, 1 by 1 plus x cube dx. Whether this value is correct or wrong, how to verify? By using the calculator we can verify the integral function. How? I am going to show you. Verify integral 0 to 4 1 divided by 1 plus x cube dx, which is equal to, see, use the calculator, press integral function 1 divided by 1 plus alpha closing bracket x, shift cube, lower limit is 0, upper limit is 4, press equals. We get 1.1781. We get 1.1781, which is nearest to the approximate value. Whatever we have got, that is 1.2033. See, first what we are supposed to do, first represent the Weddle's rule. After representation of the Weddle's rule, represent the integral function, represent the terms, set term by term, 0, h, y equal to f of x and n. Considering this, represent the what tabular column, that is interval. Corresponding to this interval, represent the function value y0, y1, y2, y3, y4, y6. What is n? 6. But ordinates are 7. 1, 2, 3, 4, 5, 6, 7. Now represent the formula, simplify the terms, represent the solution. Verify. See, it is not necessary that the integral function, whatever we have got, should be the same value for the Weddle's rule. That is not possible. But here we can predict the approximate value, not the exact value. If these two are nearest or approximate, we can directly conclude that the whatever we have found, it is correct. I hope you have understood the each and every step of the Weddle's rule. For more videos, please do like, share and subscribe. See you in the next video. Thank you.